In this video, we are going to learn how to solve an equation by completing the square. Now, I have the steps here on the left really written out, but I'm going to explain them as I go through an example here on the right. So we're going to solve each of these quadratic equations by completing the square. So first, we want to rewrite this equation so that it has the form x squared plus bx equals c, or some sort of constant. So if I see here, I have 3x squared minus 12x plus 6. If I subtract 6x, I'll get 3x squared minus 12x equals negative 6. But I want this to be just a 1x squared, so I'll divide everything by 3 as well. Give me x squared minus 4x equals negative 2. But now I want to complete the square, meaning I need to take half of this b value and square it. So meaning that b value there is negative 4. Half of that squared would give me negative 2 squared, which is 4. So if I have to add 4 to each side of my equation. So x squared minus 4x, I'll add 4 to the left side of my equation, equals negative 2 plus 4. And now I will factor it. So this is a perfect square trinomial. So the outer two terms are perfect squares. So going to factor it, I'll see that x minus 2 squared is its factored form. Double checking that. X squared is x squared. Negative 2 squared is positive 4. X times negative 2 is negative 2x, and twice of that is negative 4x. So we're good. And then negative 2 plus 4 is 2. Now I will find square roots. So I'll take the square root of x minus 2 squared and the square root of 2, which isn't a perfect square, but that's okay. And I'll end up getting an absolute value of x minus 2 is equal to the square root of 2. So x minus 2 equals the square root of 2, and x minus 2 equals negative square root of 2, which when finished solving will be x is equal to adding 2 plus the square root of 2 as one solution, and x is equal to 2 minus the square root of 2 as my other solution. But now I have 2x. Now, these are not fraction answers, so if you ever were to look at them on a graph, their decimals would kind of repeat forever with no pattern because of these radicals. So this is kind of the only way to get the exact solution is by using complete the square. But let's try another example. So let's say here I have 2x squared minus x plus 3 equals x plus 9. So I need to get all my x's on one side, x squared and x on one side, with my constant on the other side. So I will subtract x, giving me 2x squared minus 2x, and that's going to equal, when I subtract 3, 6. Now my leading coefficient is 2, so I'll divide everything by 2. So I'll have x squared minus x equals 3. And now I will complete the square. Now that is a negative 1 in front of the x. So I need to add to each side negative 1 over 2 squared, which is 1/4. So I'll have x squared minus x plus 1/4 equals 3 plus 1/4. And now I will factor, and the way this factors is the quick way to do it is to take half of that negative b. So it'll be x minus 1/2 squared. That will, negative 1/2 squared is 1/4, x squared is x squared. Then we have negative 1/2 x, and twice that would be negative 1x. And then you have 3 plus a fourths. So again, you're thinking here 12/4 plus 1/4 to add them together, because 12/4 is 3, and that'll give us 13/4. And now I will find my square roots. So I'll take the square root of x minus 1/2 squared, and the square root of 13 over 4, which when I do this, I'll end up with the absolute value of x minus 1/2 is equal to the square root of 13 over the square root of 4, which is 2. And now I can break this up into my two equations and solve. I'll have x minus 1/2 is equal to positive square root 13 over 2, and x minus 1/2 is equal to negative square root of 13 over 2. I'll add 1 to the right to give me x is equal to 1/2 plus the square root of 13 over 2, and x is equal to 1/2 minus the square root of 13 over 2. And since I have a common denominator, I can write my answer as x is equal to 1 plus the square root of 13 all over 2. And my other answer can be written as x is equal to 1 minus the square root of 13 all over 2. So as you can see, these problems were probably not factorable since our answers had these radicals in it. So whenever you cannot factor a quadratic equation, then you'll have to resort to completing the square to solve it. And that is how you solve an equation, by completing the square.